We already learned about the data warehouse basic concept and the data warehouse modeling. And now I would like to explain about the data warehouse design and usage and some of the implementation. So please note that you can figure out the OLAP is the data warehouse and the OLTP is the transaction DB. When you design this kind of data warehouse, there are some approaches. We call it top down. I guess you know this terminology. Top down, it means from the top to bottom. Okay. Start with the overall design and planning. So it means you already know all the design and then you implement it. But sometimes it can be bottom up. So from the data itself, and yeah, you did some experiment and then you design your data warehouse. So we can make a kind of prototype, and people can say this kind of rapid prototype, and you can make your data warehouse. Sometimes it can be combined. So the combination of both can be done. And we can see this kind of design from the software engineering. If you learn in the software engineering concept, we have some design process. The first is the waterfall, is the most common design approach. First, we need to check the requirement. And then after we know the requirements, we will design. So we have the design, we will do the implementation. And after we do the implementation, we will verify, and then we will do some maintenance. So we call it, this is waterfall, because we will do the next stage after we finish the previous stage. So we finish the requirement and then do design, and then we will do the implementation, and then we will do the verification, and then we will do the maintenance. Yep. Some people propose spiral. Spiral means the rapid generation of increasingly functional system. So this spiral give you like this one. The first, you need to determine the objective, and then you can check what are the costs. So you can identify and resolve the risks. So you can start, and then you can do the development of the test, and then you can plan the next iteration. So you can do all the things. Okay. Oh, sorry. This one should be from the center. Okay. So you will start from the very small, and then you will create a kind of prototype, and then you will review, and then you need to determine another objective, and then you need to make the prototype number 2, and then you review again, and then finally you will do the release product. So we call this is the spiral. We can also deal with this kind of design by choosing the business process. So we call this is the typical data warehouse design process. We will choose what is the best business process. Let's say in the order process, there will be some sequence. Or when you want to create invoices, so there will be sequence. There will be the business process. So if this process is organizational, then a data warehouse model follow. If this model is departmental, it is only a sub-organization, then we will use the data mart. So it depends on what you want to design for your data warehouse. Or sometimes you can choose the green. The green means the atomic level of the data of the business process. So you already learned about the fact table. You still remember? The one that we learned on the fact table is about the sales. Okay. Sales fact table. So we can start from that atomic level. Or if you have like the shipping, so you can also build your data warehouse from this small or the atomic level of the shipping fact table. Sometimes you can also choose from the dimension that will apply to its fact table. Let's say you know that I want to check the time, I want to check the product, and I want to check the supplier. So you can create the data warehouse based on this one. Or you can check, you can choose the measure. So the measure means you want to know the dollars sold, or you want to know the average of dollar sold. So you can start with the measures and then you can define your data warehouse. So there are many ways to design the data warehouse. You already learned those concepts. This is the previous approaches. Okay. So some people recommend this approach. So if you have the organization, okay, you need to define the high-level corporate data model. So you can start from the bottom, and then you can define what is the data mart and what is another data mart, and you can have another data mart. So when you have many data mart, you can put it into one big distributed data marts. So as you know, this data mart, it can be in every department. Maybe this is the department A. This will be in the department B, and so on. But for the data, the enterprise data warehouse, it means this is for the whole departments. So this one for all departments. So you can design whether it is for every department or for its department. And when you already have the distributed data marts and when you have already the enterprise data warehouse, yeah, we can build this multi-tier data warehouse. So the data warehouse should have these three kinds of application. The first is to do the information processing. So you need to know how you can query. You need to know how to do some basic statistical analysis. You already did the EDA in the first chapter of our course. So the data warehouse should be able to have this kind of function. It should have the reporting with the cross-tabs, tables, charts, graphs. And the data warehouse should have the analytical processing. You have the multi-dimensional analysis of the warehouse data. And there should be some basic OLAP operations, such as the slice dice, drilling, pivoting, and etc. The one that you already learned before. And the one that we will focus on in this semester is the data mining. How we can find the knowledge or how we can discover the knowledge from the hidden patterns. And it will support the association, or maybe we will make some analytical models, or maybe we will perform classification and prediction, presenting the mining result using visualization tools, and etc. So now there are many concepts about the OLAP, which has been shifted to OLAM. So now we are in the era of Industry 4.0. People said that Industry 5.0. So they want to mine, they want to do the data mining as soon as possible. So the word online analytical mining. It means when you do this online analytical mining, you need to have a high quality of data in the data warehouses. It should be integrated, it should be consistent, and the data should be clean. If you don't have this kind of high quality of data warehouse, you will have difficulties to do the OLAM. And it should be based on the exploratory data analysis. So you can drilling, you can dicing, you can pivoting, and etc. And there should be some selection on the data mining functions. You need to know what are the functions so you can integrate, or maybe sometimes you can swap with multiple mining functions, or you can swap with different algorithms, or you can swap with the different tests. When we are dealing with this kind of data warehouse, we need to measure about the data cube. So you need to know what is the efficient data cube computation. It means you cannot build a very big data cube. If you look at this one, data cube can be viewed as a lattice of cuboids. So you already know this lattice of cuboids. The bottom is the base. The bottom is the base, and the topmost is the apex. It means it will have only one cell, so it combines, or it is a zero dimension. So we will check how many cuboids in an n dimensional cube with L levels. So L level means if we have n in a number of integer, we can also have the L, which is a number of integer. So let's suppose we have n equals to 3, and then each dimension has one level. Okay, so we can follow this formula. T is the, do you know this one? This is product. We call it product. Or the simple meaning is multiplication. Okay, we will do the multiplication. Sigma is summation. You will add. For example, if we have sigma xi from I equals to 1 until n, then it will be x1 plus x2 plus x3 plus until xn. Okay, but if you use this product, let's say we have xi from I equals to 1 until n, then it means we have x1 multiply x2 multiply x3 multiply until xn. So we have the formula Li plus 1. The level means, let's say we have one level means the hierarchy. Okay? You know, if we have the location, you can define the location as the office, and then you will have the city, and then you will have the district, let's say, and then you will have, oh, maybe so, first district, and then city, and then country. So we have the hierarchy. We have like 4 levels. Now let's just assume we have only one level and we have 3 dimensions, or we have 3 attributes. So the formula, how many cuboids that we can construct is 1, okay, because we have only one level. So one level in the dimension I plus 1. And we have 3. So we will do with the power of 3. So we will multiply 2 multiply 2 multiply 2. Then the result will be 8. What is this 8? You can have like 1, 2, 3, 4, 5, 6, 7, 8. Okay. We have 8 cuboids when the n is equal to 3, and for each dimension we have one level. But what about if we have n equals to 10 and each dimension have 4 levels? So each dimension have 4 levels. So it means, we have location. In location we have 4 levels. Item. In item we have 4 levels. And then let's say we have supplier. Supplier have 4 levels. Okay. So every dimension have 4 levels. Then we will have like this formula. For every dimension plus 1, and then we have 10 variables. So you can know how many cuboids that we need to create. So if there are a lot of levels and if there are a lot of dimensions, of course, it will create a very huge cuboids. So you need to do the efficient data cube computation. So you can use this formula to measure how many cuboids that you will create. So I give you this example. So a data cube with the dimension. So time, location, and item. So you can just use the 2 multiplied by 2 multiplied by 2. So just assume that the cuboid contains time or not. And let's say if we have time have 3 levels. So we have the month, we have quarter, and we have year. And if we have 4 levels, so it means, if we have 3 levels, so we have 3 plus 1 for the time, but the other dimension will have only 2. Okay, we will do 1 plus 1 and then multiply with the other, which is 1 plus 1. Then we will have 4 multiplied by 2 multiplied by 2. So we can see how many cuboids that we can build. So this is the assumption that we have the time, location, item, and the time has 3 levels. And the other, which is location, we have only 1, and the item we have also only 1. Okay. We need to do this efficient data cube computation by materialization. What is materialization? So the materialization means we need to check the Q points. If you want to use for every Q point, it means you will use full materialization. The worst case, yeah, there will be none or no materialization because you will not use for every Q point. But there can be also some or partial materialization. What we learn from this formula, it is the total. The total. Or we can say this is using the every materialization or full materialization. Okay. How we can select which cuboids to materialize? Yeah, there are many ways to select. You can select maybe based on the size, or maybe some companies they want to share only some cubes, or there can be some access on the frequency, how many people who access the data, and so on. So if you are in the database class, yeah, if you join the database class, I guess you know some query language. We call the DMQL. So we can define the cube and the computation in data manipulation query language. So for example, I can define the cube sales. And then I would like to get the item and the city and the year, and I would like to do the summation. So this sales in dollar is the attribute name. And you can compute the cube sales. So this is one example of the DMQL, data manipulation query language. Or some of the data warehouse, they will use the SQL-like language. The SQL-like language, you can use the operator cube by. Usually in the SQL, we have the group by. But when we deal with the data warehouse, we can use cube by. For example, if we select the item, city, year, and then we want to get the sum from the table sales and cube by item, city, and year. So we will make the cube, the single cube with the 3-dimension item, city, and year. Yeah, you can compute also with the group by. The group by function is very powerful to make some data based on the particular attributes. Maybe you want to get the data with the date, product, and customer. You want to get the data with the date and product, date and customer, product and customer. Or you want to get only the date, you want to get only the product, you want to get only the customer. Yeah, you can use this kind of SQL or the operator. Yeah. So what I explained before, we can define what is the materialize that you want to select. So if you select the full materialize, it means you will select all attributes. If you want to partially select, then you can select only some of the attributes. So let the query to be processed be on the brand and province or state. So I want to select only these two attributes. And I have the condition. Let's check only the product in the year 2020 on this particular brand and in this particular province. Then we can have maybe this is an example, you can make 4 materialized cuboids. The first is you can define the year, item name, and city. You can have your next materialized cuboids, year, brand, and country. Or you can define year, brand, and province or state. Or you can have your next materialization item name, province or state, and you just make a condition year equals to 2020. So those are the option to make the materialized cuboids. But which should be selected to process the query? We can do with this one. We can do with this one. We can do with this one. But if we have the condition, if you open this one, if you open this, yeah, it will show maybe almost full materialized cuboids. So sometimes we need to give condition. So the best way to do the query for this one, yeah, you need to make some kind of condition. So when you are dealing with the OLAP, you need to consider the efficient processing. Sometimes you need to determine the time. The time, if you make the time very long, 10 years or 20 years, the data will be very big and then it is not efficient. And sometimes, yeah, the hierarchy, okay, the hierarchy should be also considered. You need to choose only one hierarchy. If you choose like, I want to see the city and the province, okay, so it's not efficient as well. In the OLAP server architecture, there are some architectures. Yeah, this is only just a reference for you. If you are later on working on this kind of job function, like the data warehouse or the database administrator, you can understand some of the keywords. Relational OLAP. So this relational OLAP, it is based on the relational or extended relational DBMS. So DBMS, it is the database management system. So if you join the database class, I guess you know the relational database management system. And the data warehouse will use similar with this database. It will include the optimization of the DBMS backend, implementation of the aggregation navigation logic, and additional tools and services. So if you use the big DBMS like IBM, okay, or Oracle or Postgre, okay, there are many big companies use the DBMS. So they provide the data warehouse with the similar function of DBMS. And yeah, it is greater scalability. So if you use the big companies for this relational OLAP. But there are many options. You can also use this multi-dimensional OLAP. This multi-dimensional will use the sparse array-based multi-dimensional storage engine. So if you understand the data structure, you know about array. So if they use array, it means they will put everything in a kind of list. So this use the sparse array-based multi-dimensional storage engine. It is fast indexing to pre-computed summarized data. So if you have the database management system, they will not use this array-based. So they have different ways. Or some of the tools, they are hybrid. Like the Microsoft SQL Server, they have the flexibility, what you want to use. If the data is in the low level, they will use relational. If the data is in the high level, they use array, because in the high level, they need to make the summary. Okay. Can you mention the data warehouse design process? We have several design process, like the top down, bottom up, and then if we are looking at the software engineering, there will be the waterfall and the spiral. Okay. And there are some typical design. As you already know, we can use business process, and then we can start from the grain. The grain means the atomic level of the fact table. Maybe I can just say fact table. Okay. Or we can start from the dimension, which is the attribute. Or you can start from the measures, which is the numbers that you want to show. Okay. So mention the three kinds of possible application from data warehouse. The three kinds of possible application. We have the information processing, we have analytical processing, and we can do with the data mining. And how many cuboids in a 4-dimensional cube with 2 levels? So this is the n dimension, and the level is the L. Based on the formula, we will do the Li plus 1. So based on this problem, every dimension will have 2 levels. So it means this is 2 plus 1, and we have 4 dimensions. So we will exponent with 4. So 3 exponent 4. '81. So there will be 81 cuboids created for this 4-dimensional cube with 2 levels. So what are the OLAP server architectures? So we have several architectures. The relational OLAP, and then we have the multi-dimensional OLAP, and we have the hybrid OLAP. Okay. So that's all we learned about the data warehouse. Any questions, comments?